Practice problems in section 12.5.2, and this is our last one, number 21, dealing with the 3D equations of lines. This one actually is a question about the distance between a point and a line. So let's draw a little picture. Here's our line, and here's our point. I'm going to label it point A. And what we want is this distance right here, the perpendicular distance between the line and the point. And it turns out finding this distance is tricky. We'd have to find actually the point of intersection between the perpendicular and the line, and then find the distance between those 2 points. And that's not easy to do. That's not actually the way we're going to proceed with this. Instead, what I need to do is identify any point that lies on this line. I'll call that point B, and then we're going to get the vector BA. Next, I need a vector that actually lies in the plane or in the line, and that'll be vector V. So once I have V and vector BA, look at what we can do. I know that the cross product of vector V with BA, its magnitude is going to be the same as the area of this parallelogram. And of course, the area of a parallelogram can be calculated in 2 ways. One is by the cross product of the vectors that represent the corner, and the second way is by taking the height times the length of the base. And of course, the height, that line right there, that's exactly what we want. That height will in essence give me the length of the projection of vector AB onto the perpendicular between point A and this line. Okay, so let's go ahead and proceed. I need a point B which lies on the line, and this vector will give it to me, 2, 2, 0. And the reason why that works is that this is the vector from the origin to a point on the line, so I know that point lies on the line. Next, I need the vector V, which represents the direction of the line, and there it is right there, 1, 2, 3. Okay, first we need to find vector BA, and that's just taking the endpoint A and subtracting 2 minus 2 is 0. Negative 1 minus 2 is negative 3, and 1 minus 0 is 1. So there's the vector BA. Next, I need to take the cross product of BA with V, and of course to do that, I'll need the matrix I, negative J, K. I want the cross product of BA cross V, so BA is next, 0, negative 3, 1, and 1, 2, 3. So let's go ahead and find this cross product of the vector that goes to our point from the line and a vector that lies in the line. Okay, blocking off the I row and column, it's negative 9 minus 2. That's negative 11. Blocking off the row and column with J and adding an extra negative, this is 0 minus 1. So negative 1 and another negative is positive 1. And then finally blocking off K's row and column, we've got 0 minus a negative 3, so that's 3. So there's the vector that represents the cross product between BA and V, and its magnitude will actually be the area of this parallelogram. So let's find its magnitude. BA cross V's magnitude will be equal to 121 plus 1 plus 9. So this is going to be 131 under the radical. Well, we know that the height is going to actually be equal to the magnitude of this cross product, BA cross V, divided by the magnitude of V. The magnitude of V is going to be the square root of the sum of the squares of its components. So that's 9 and 4 is 13 and 1 is 14. So this will be the square root of 131 divided by the square root of 14. And that's it. We can certainly rationalize the denominator if we're interested in it, and we can convert it to a decimal number. But that right there, that is the length of the segment joining point A to a perpendicular to line provided by 220 plus t times 123.